Yeah, this is solubility of gases. Unlike solubility of solids, which increases with increase in temperature, as we've seen potassium nitrate and then potassium chloride. So gases do not react with water. I mean, solubility of gases decreases with increase in temperature. So if you've listened carefully when we were treating the solubility curve, you realize that when temperature increases, the amount of solute or saturating the solvent also increases. In gases, when the temperature increases, the amount of gases decreases. So solubility of gas in a liquid is directly proportional to the partial pressure of the gas above the liquid. So it is directly proportional to the partial pressure of the gas above the liquid. That's solubility of gas in a liquid. So if you take, for example, a bottle of Coke or a can of malt, those arid drinks, they have dissolved carbon dioxide that stays in the solution in a closed pop or bottle. So those carbon dioxide, they are gases. They are bottled up in the can or in the bottle of Coke. And then, so it means that the solubility of the gas in that liquid is directly proportional to the partial pressure of the gas above the liquid. So if you look at a bottle of Coke, you notice that there's a cap on top. So that's where the carbon dioxide is bottled up, pressurized. So what happens is that when the can or the bottle is opened, the partial pressure is much lower, and the dissolved carbon dioxide will gradually escape from the pulp. But when bottled up, the pressure is high. Okay, it's high. But when opened, the pressure reduces. And then the CO2 evaporates. Don't mind my pen, it's just this way. My handwriting too. So that's on solubility of gases, but I don't think this information. There are different factors affecting the solubility of a gas in a solvent. Number one is the nature of the gas. Number two is the nature of the solvent, then temperature, and then pressure, in case you come across it in one of the objective questions. Right. Solvents. Solvents can be classified into two: organic solvents and inorganic solvents. So water is an example of an inorganic solvent. It is polar in nature, and then it dissolves most inorganic substances, as well as some organic substances that contains hydroxide group to form aqueous solution. So examples of inorganic solutes and organic solutes that dissolve in water are: number one, mineral acid, dissolve in water, soluble bases, minerals, mineral salts, salt here, I think let's cancel it here. So these substances dissolve. But these organic substances dissolve in water. Sugar, as you can see, stop moving. Sugar dissolves in water, and then glucose. So it's important to note that besides all these gases that can dissolve, in water to some extent, there are gases that ionize in solution or react with water, and those gases are very soluble in water. Some of them are ammonia, hydrogen chloride, nitrogen, and sulfur trioxide. And then again, we also have other gases like sulfur oxide and carbon dioxide and chlorine. They ionize in water and they are fairly soluble. And then the last part, there are gases that do not ionize at all in water. They are sparingly soluble. They are carbon dioxide, oxygen, nitrogen, and hydrogen. So these ones are gases that do not ionize in water. So I think it's important you know these things. They might come out as one of organic solvents. These are mostly covalent compounds that can dissolve in organic substances. There are solvents that can dissolve in organic solvents. Examples of the kerosene, I think the turpentine, so it should be here. And I know if I'm writing it will be a problem. Oh, rather, that's the name actually. So kerosene, petrol, benzene, turpentine, they're mostly obtained from crude oil. They are regarded as organic. So what you need to know about these solvents are their uses, and they often come out in past questions. You see a bundle of them. So water is a universal solvent, is suitable for most chemical reactions. Petrol dissolves fats, oil, grease, and stains. It's used in the laundries for washing clothes. It's also used for cleaning household equipment. Okay, because it can remove stains and wax and all those things. So kerosene dissolves fats, oil, and grease. Also used in the laundries. Turpentine. It's used to mix waterproof paints for the painting of walls. It's also good in the paint industry. It can also be used to remove stains of paint in the laundry. Then we have ethanol, which is used in the manufacturing of perfume oils and are dissolved. Okay, such oils can also dissolve in ethanol. You also use it for the cleaning of surgical equipment in hospitals. The last one is that it can also be used in the laboratory when you want to extract the green pigments in plants or in leaves. So you boil the leaves in ethanol, and then you'll be able to extract the green pigments, otherwise known as chlorophyll. Benzene. When a rubber is dissolved in benzene solution, the resultant solution can also be used by the vulcanizer to repair a punctured tire. We have carbon tetrachloromethane, and it's used for removal of the stubborn stains during laundry. Also, a coffee or tea stain can be removed by a solution of borax in water. The last one is iodine solution, prepared by dissolving solid iodine in ethanol. It's used for dressing wounds in the dispensary. If you have a cut or a burn, just put a little bit of iodine. So these are the solvents, and then their uses. Make sure you remember them because they're quite often see them in the examination hall. The water, the kerosene, the petrol, the turpentine, ethanol, benzene, iodine solution. So the most important thing about these things is to know which produces which, like benzene. Rubber can be dissolved in benzene solution. Then ethanol, solid iodine can be dissolved in ethanol. Then coffee stains can be removed by borax, solution of borax and water. Then in chlorophyll, you talk about ethanol. And then turpentine, used to remove paint stains. So that's it for now. Go over to the last section.